So this is going to be a kind of like fairly relaxed, informal affair. So if you've got questions or you want to like ask something whilst I'm talking, then just either stop me or put your hand up or whatever you want to do. I don't want to kind of ramble all the way through to the end and then then be sat here in silence. So as Lisa said, I'm going to talk a little bit about what it's like to do research in these type of environments. So this is me on the right here down in Antarctica, doing a kind of ethnographic type observational piece of work. And obviously, in these environments, there are a variety of things to consider on top of being able to do the research that you want to do. You can't just kind of, in this instance, you can't just take my gloves off to make some notes and things like that. So there's lots of considerations that you need to make when you're trying to do this type of work. So what we'll kind of discuss today is how you do research with these types of extreme teams, and I'm going to talk a bit more about what I mean by extreme teams in a minute. And then I'll just touch a little bit on the theoretical aspects, some of the methods, and some of the analytical considerations that hopefully you'll be able to kind of think about in relation to what you're doing. Some of it might be directly relevant, some of it might be kind of tangential, but might be able to be applied. So I guess if we're going like high level, like right out there, what's the point of studying extreme teams? In the next 30, 40, 50 years, there's a very high likelihood that we are going to be sending people beyond our planet, past the moon, out into space, potentially to Mars, but potentially to other planets as well. And so this is probably the best example of an extreme team that you can find. The idea of putting people into a little capsule and blasting them away from Earth and letting them kind of survive and create a community in these environments. But there are lots of other extreme teams that need our help right away. This is a kind of fictitious scenario at the moment. We aren't sending people to Mars yet. But we do have teams all over the world doing things in kind of extreme and dangerous places. So probably the most obvious one is these types of extreme military team. Little, small groups of people that are highly interdependent, that rely on each other to complete activities in what are kind of dangerous and hostile situations. They operate in the whole range of extreme environments, from the polar regions to jungles, deserts, mountains, and all things in between. There are also other types of extreme groups. So there's also military is a very distinct example and a kind of subset of the population, but there are lots of others. So we're doing some work at the moment with WWF looking at their wildlife rangers. And being a wildlife ranger is one of the most risky jobs that you can do in the world. Hundreds of rangers every year are either mauled by the animals they're trying to protect or killed by the poachers that are trying to get the big animals. So it's a very dangerous occupation, and there's lots of issues related to people being posted out into the field and the stresses that they're placed under. So trying to understand what it's like for them is really important. So what I'll try and do, so I've given you some examples there, but what I'll try and do is give you a bit of a definition of what an extreme environment is. We're all academic, we love definitions, so we'll start there. I'll talk about some of the theoretical perspectives that underpin this work, some of the methodological considerations for actually going and securing data from people whilst they're out in the field, and some things that you, if you're interested in doing this type of work, might have to think about, and then how we might manage and handle and analyse that data to give us some kind of useful information at the end of it. So extreme environments, we typically classify extreme environments as settings that possess extraordinary physical, so environmental things, psychological and interpersonal or social aspects that require some kind of adaptation for us to survive, but then also to perform well and to stay healthy in these environments. You'll sometimes hear people talk about the extremeness and unusualness of these things. So we might be we might live somewhere where we have to deal with some of these things already. Walking through Manchester, you might see people that are living on the streets that are already dealing with kind of physical, difficult situations that might also be psychologically and socially stressful. But what we're talking about with extreme teams is people that are going away from their norm into an environment that is putting a bit more strain on these things, and that could be that they're really extreme or that they're just really unusual, and that places stress on someone. And if they're not addressed, then the consequences could be quite severe, which we'll have a look at in a minute. So, but what does this actually mean? So When we talk about environmental stuff, we're talking about the physical things, the objective things that we can look at, so, or that we can put our finger on and measure in some kind of way. So we're talking about things like temperature. In the polar regions, it can get really cold. In deserts, it can get really hot. In jungles, it can get really humid. We might be talking about the terrain. So on mountains, the terrain can be quite difficult. Carving a path through a jungle can be really hard. The terrain in itself can be quite stressful and challenging. But there might also be things to do with the light-dark cycles. So at the higher latitudes, so kind of in the Arctic and the Antarctic, there's kind of 6 months of almost complete darkness and 6 months of almost complete light, and that can have an effect on circadian rhythms and how people react, kind of seasonal affective disorder and things like that. And just to give you an example, so this is a cave experiment that Michel Chiffré did in 1962. So he went and lived in a cave for 2 months on his own. I'm not quite sure why, but he said it was to test whether he could stay sane during that time. He quickly realised that his whole concept of time disappeared. He would sleep for hours and hours at a time, and he basically lost his concept of time by a factor of 2. So he thought it was only 2 weeks, and it was actually 4 weeks. And so that it has a really severe effect on how people react. Psychologically, these are more things to do with your individual experience. So, a lot of the time we talk about extreme, and they sound quite exciting, and you get the adrenaline rush and the buzz. But oftentimes, it's sad to say, is these places can be very boring. You might be doing very repetitive tasks, just repeating things over and over and over again. There might be, obviously, isolation. Some of these places are quite cut off. Down in Antarctica, if you're around the coastline, it can be 3 or 4 days before you can get back to any kind of civilization, some kind of medical care and things like that. There's often enhanced kind of feelings of threat. So there's risk associated with these things. If you make a wrong move or you step on the wrong part, you might end up on a crevasse. You might fall off the side of a mountain. Less than ideal for staying alive. You might also be experiencing some kind of sleep deprivation. So if teams like the military teams or the rangers that are going out and doing work in these places, the operational side of what they do might mean that they have to be awake for long periods of time. So they're probably going to experience some kind of sleep deprivation. Even if they're not doing things, the environment's probably that uncomfortable that getting to sleep can be quite challenging. And then there can be issues with sensory deprivation. So imagine spending 3 months in this. So this is what we call a whiteout condition in Antarctica. You can't see the ground from the sky. People have to, when they're doing expeditions, they might be skiing in conditions like that for 2 or 3 weeks at a time. And they say that it's basically being blind. You can't see anything. What they normally do if they're skiing in pairs or in a team, every 45 minutes or so they will rotate who's leading so that they've got something to look at, and they'll wear bright clothing to give them a bit of stimulation, or they'll keep looking around so they can see their hands, so they've got some kind of perception of distance. I was just saying to someone earlier at the start, there's a few people down in Antarctica at the moment trying to do solo skis to the South Pole, where they basically attach a sled to them and they just ski every day for 3 weeks or 4 weeks. What you'll find is if you go and look at the blog post, what they talk about is they'll have days when it's like this, where they just keep falling over, like flat on their face. And it happens, 12, 15 times a day because they can't see anything in the landscape. So, gradually they're getting further and further forward until they're just face down in the snow. Sounds fun. There then is the social aspect of doing things in these places. So the physical stuff, you kind of know it's going to be like that when you go out there. The psychological stuff is individual to you. But probably the most difficult part for these environments is the social stuff, where you have to go with a group of people and you have to live and work with them very closely for a long period of time. You might be sharing a tent with someone, and so every night you have to sleep, literally 30 centimetres apart, and that might go on for weeks or months at a time. So it can be quite difficult, compounded by the fact that you might be away from friends and family. You might be cut off from any other outside social support. And just to give you an example, so This is Valery Ryumin and Nikolai, and Budarin, and they were cosmonauts that were on I think the space station Mir at the time. They looked quite happy here, but after the mission they got back and they said, and Budarin said this: "So all of the conditions necessary for murder are met if you shut two men in a cabin measuring 18 by 20 feet and leave them together for 2 months." Basically, if you put two people in close quarters for a long period of time, something bad is going to happen eventually. There's quite a lot of evidence for this. Recently, there was a case of a Russian scientist down in Antarctica that actually stabbed one of his colleagues. The rumour is that that's because his colleague kept telling him the endings to the books he was reading. And after a year of darkness and isolation and confinement, that just tipped him over the edge. So there are lots of, I've painted a picture of how extreme these places are. There are lots of groups that have to operate in what we might consider to be extreme environments. Examples, special forces personnel, search and rescue. They don't have to be far from home. Search and rescue go out onto the Peak District and the Lake Districts all the time, all the year round. Anti-poaching rangers. You might be doing remote field work, so you might actually be a researcher that has to go out into the field, into these extreme places. You might be humanitarian response teams. We've got the HCRI at Manchester. They've got people that go out into the field to what are pretty extreme places. If you're dealing with things like Ebola, for instance, you're going to a low resource, quite difficult environment, which is going to place strain on you. And then obviously you've got people like astronauts and cosmonauts. I've put etc. because there is a list as long as your arm of these types of extreme team. Even this morning there was I nearly adapted the slides, there was an article about them laying new cabling between the UK and Belgium. When they do those sorts of things, divers have to go down. They might live in a saturation chamber and they have to do work underwater. That's quite extreme. The importance of studying them is for us to understand how to assess risk, provide some evidence base for the decisions that we're trying to make, and to try and keep them safe and healthy out in the field. If we don't get this right, then the consequences can be quite severe. Okay, so this isn't for the light-hearted, but here we've got someone that's made a mistake on a mountain in a high altitude region, and this is what frostbite looks like. When they get back, they're probably going to lose all of those fingers. You've got this is the one I mentioned earlier, the kind of Russian scientist that got arrested, the rangers that are facing kind of toxic conditions that's not good for your mental health, saturation divers, that's kind of isolated, weird kind of job that's quite dangerous. There's then also, so you've got the physical kind of injury or harm that can come to people. There's also the reputational damage that can be done to the organisations that are sending people into these places. So I don't know if anyone's come across the podcast, The Habitat. No. So The Habitat is a really good podcast, well worth a listen. It focuses on a group of people doing a confinement study for NASA, and they lived in this confinement chamber in Hawaii for 12 months. And the journalist that was recording them asked them to do kind of voice diaries throughout. And throughout the confinement study, you see the group gradually becoming more and more detached from each other. And by the end, the station commanders everyone hates her, and then they've kind of split off into subgroups. It's quite an interesting kind of observational piece of work. There's also kind of issues when these simulations have to be cancelled. So it's not uncommon that when they do these simulation studies, they have to stop them early because people are either taking too many risks, not getting on, people are struggling with their health. There's a couple of famous examples. I think there's one from an old Russian simulation study that they had to stop because they went on food strike and they just were like, I'm not eating what you're giving me. So people can get quite stressed and make interesting decisions in these places. There's a bit of an issue though. So we know that these people need our help. We know that they need support in order to function and stay healthy. But it can be quite difficult to study these teams when they're out in the environment, partly because it's quite unpredictable. So I'll give you an example. This is an example of a military team going out to take back an oil rig. This is probably a simulation, so they're worried that terrorists might go and try and take control of an oil rig and hold them for ransom. The people that are on there. It can be very damaging politically, so they go and send these teams out to practice kind of taking back the oil rig. We don't know when these types of situations are going to occur. So for us to try and study these people when they're actually doing their task is really, really difficult. And that's the same for all the other operational type teams. We can't predict when they might be deployed, and we probably wouldn't be able to study them when they're deployed either. So lots of research on these types of groups has been done with kind of simulation and training scenarios. They're useful, they've provided lots of evidence, but they don't give us the kind of true sense of what's going on in the environment with the level of danger and the level of risk that is actually inherent to these types of tasks. But it is still important to try and study them. So what we tend to do is use analog groups. So other groups that are going and doing things in similar types of environments under similar conditions that we might be able to learn from and extrapolate data from. So that might be expeditions going and trying to summit mountains, cross deserts, ski across polar ice caps, that sort of thing. And we use those to kind of extrapolate data back. In terms of kind of assessing and understanding what we're interested in, I just did a quick kind of landscape sweep a couple of days ago and just pulled out some of the things that are really high priority for big organisations that are kind of playing in this space. So, you know, NASA, probably the biggest one. They spent a lot of time producing a human research roadmap that is designed to de-risk long-duration space travel. At the centre of that is the risk of performance and behavioural health decrements due to inadequate cooperation, coordination, communication and psychological adaptation within a team. Very clearly there's a need to understand how to stop that happening. The WWF have highlighted the need to understand occupational stress as perceived by rangers, how to understand to stop post-traumatic stress disorder and what people might do in the field to mitigate these things. And then just very recently the UK Defence and Security Accelerator have suggested that they need solutions to support personnel during training and operations in preparation for rapid reaction and deployment on long duration complex operations in challenging environments. So there's very clearly a need from end users, stakeholders, governments, organisations to actually understand how teams function in these extreme places. So hopefully I've convinced you that we do need to do this research, and that keeps me in a job for a little bit longer. I guess the next step then is, okay, what are we trying to understand? What theoretical frameworks are we trying to pull from to actually determine how teams function and how individuals react to these extreme conditions? You probably gathered already that this is a very kind of pragmatic research area. Going and doing research with teams in extreme places requires you to be a bit adaptable. You're not always going to be able to execute the study to the exact same level of rigour and control as you could if you were doing it in this classroom, say. But it does still need to be underpinned by good theoretical decisions, which helps us understand why things might happen in the way they do. So I'll start with the kind of individual. So I'm not saying this reflects kind of the complexity of the human experience in extreme environments, but a very simple inverted U model. The demands of the conditions will influence how someone performs, whether that's performance, health, safety, whatever it is. At some point there's going to be a peak. So someone goes into these demanding environments, the demands are quite hard, but they'll be able to cope and they'll stay well and they'll perform to a sort of good standard. If those demands become too much, that will eventually drop off. That's a very simple example. We know that appraisal theories are the ones that tend to be used in extreme environments, and the reason that is because they focus on how stress is interpreted, how it's appraised, whether it's seen as challenging or threatening, and then tell us something about the reactions that people might have, the coping strategies they might use, and whether they stay healthy or not in these situations. So things like Lazarus and Folkman's classic kind of cognitive motivational relational theories of stress, Ursula and Erickson's cognitive appraisal theory, things like that give us some information about how we might keep someone in that kind of optimal zone of functioning and health. These theories predominate, so most of the literature will talk around these areas, mainly because they tend to pick up on the demanding kind of physical and psychological stresses that are faced, so it makes sense that you'd use these approaches. The application is not always that wide. So the breadth and depth and quality of how these theories have been applied can vary between studies. There's also another problem when you're studying teams, is that we're not only interested in the individual. So if we're deploying a team, maybe a military team out into an Arctic environment, there's probably going to be 5 or 6 people in that team. So then you've got that individual, but you've also got 5 other individuals that are all interdependent, they're all reliant on each other to stay safe and well and to perform the tasks. So you need to start then considering how each person is impacting on the group function. So something like Steve Kozlowski's multi-level model of teams is quite informative here. So it tells us a bit about how the individual differences associated with each person will impact on the overall team function, which is usually more than just the sum of its parts. So we're starting to get a picture of how complex these teams are. Other questions then arise is, okay, so what if one of the team members now is overstressed, so their performance or their health starts to deteriorate? What impact does that have on the rest of the group? And then you might go a step further and say, what if that person either has to be evacuated or something even worse happened? They might die on the side of a mountain, or something quite severe could occur, leaving the team now one person short, and tasks have been allocated so that they can all complete the tasks. They're all reliant on each other. And what effect does that have? I'm just going to ramp it up a little bit and then say, without considering time in all of this, we're not getting the true picture. Because if we drop a team of people into a cold place, the Arctic or the Antarctic, on day one, when they're fully rested, they're really healthy, they're trained, they know what they're doing, they're probably all going to be at the peak of their performance and health. But what about 30 days later, when they've been walking and hiking and doing activities for 8 or 10 hours a day? So without considering some concept of time, we're not getting the true story here. So any methods or theories that we apply should account for that kind of dynamic temporal perspective. So what then do we do? There are a variety of things that we can do to try and tap into some of this stuff and understand the theoretical aspects a little bit better. I'm going to just talk through some of the work that we've been doing and some of the approaches we've taken. So this is our team for now, so we've got these 4 people. What would normally happen in extreme team research is, before these people go out, you would do some kind of assessment, and that might be a questionnaire, it might be some kind of physiological fitness testing or something like that. They go out, and when they come back, you test them again and you see what's changed. That tells us nothing about what actually happened and the dynamics that were occurring in the environment. You can get it retrospectively, but it's not going to give you the true picture of what was going on. So what we've started to do is we've started to build up this methodology. So we now do things before and after. So we're kind of building on research that's come before, but we're also sampling people whilst they're out in the field. And I'll talk about how we do that in a second. By doing this, we start to get quite a complex data set. So we have all of these people, we have the kind of dispositional stuff, we have how it's responded when they get back. We also have their daily experience while they're out there and their reflections of what's been going on. So we're starting to build what is in effect a nested data set. So within each person, here they might be out for 6 days, so we've got 6 days worth of data in a person, and we've got that for all of our team. And that combines into a team level structure at the top. We might then have 2 or 3 other teams that also have this nested structure. So it starts to get methodologically quite complex when we come to analyse that data. But that's the approach that we've been taking with our research. There's something in terms of when we're doing that type of research that requires us to start to think about the types of methods that we're using and the selections that we make before we study these people. There's a broader issue here that applies across not just to extreme teams, but more broadly to psychology in terms of measurement standardization. There's lots of measures developed, and then they're all tapping into something that's slightly maybe slightly different, but more often than not quite similar. We at the point now are needing to go, okay, what stuff gives us what we need to assess that construct? So there's a kind of refinement activity that needs to go on. This is also really important in extreme teams where the numbers of people are quite limited. So you can't just go out and recruit more people. The aim for lots of people in this field is, can we develop a set of standardized measures that we can use to study hundreds of teams across 20 research groups all around the world, which we can then combine? And that's an activity that NASA have been doing for the past few years. They actually call it the Standard Measures Project, so identifying what individual and team measures they can develop and be used with lots of groups. There's also an ethical thing to think about. When we are studying extreme teams, they're very small in number, and you can probably identify who they are. So if I say to you kind of, oh yeah, we're studying this polar expedition team that are trying a certain type of polar crossing, it's probably been in the news. You could probably figure out who those people are just by me telling you what expedition it is. I wouldn't even have to give you the name. So by standardization and recruiting lots of teams, we remove that kind of ethical concern of revealing identities. That's really important. It's a kind of a sort of side issue, but it is an important ethical consideration. Once you've kind of done all that sort of stuff and you've selected your measures, you then have to start to think about how you might secure that data from the field under those kind of logistical constraints. People can't just take their gloves off and fill something out. They can't just stop what they're doing to do your measurement because they might be doing a safety critical task. So there's lots of things you need to think about in terms of how you deliver the measure. The method that's probably got the most promise is the experience sampling methodology that you might have heard of before. It's been used kind of widely in psychological research. There are different ways that this can be delivered. So you can use what we call an interval contingent approach. So that is that people fill out the measure at the same time every day. So you've got some control across the testing period. That's the approach we've taken with our expedition diary. What we do is we ask people to fill it out at the very start of the day, so just after they've woken up, and then at the very end of the day, just before they go to sleep. The benefit that has when they're out in the field is that they're usually doing it in their tents, so they're warm, they can have their gloves off, they can be filling stuff out, they're settled for the day, so they're not having to juggle multiple tasks. There are other ways it can be used. So there's an event contingent approach, so where a trigger happens, and then every time this trigger happens, you respond to some kind of measure. Or a signal contingent approach. So you might have a device, an accelerometer or a watch or something like that, that gives you a beep and tells you to respond to some kind of questions. If you're going to use those types of approach, regardless of setting, you have to think about the context. So when is this going to be delivered, and is it feasible for the person to do the activity? Just as give you a couple of examples, so we've used kind of paper diaries, and we'll be using electronic logging type systems. On space, they've developed this thing. I'll call it Simon because I don't know its exact name. I think it's Simian, but it's basically a kind of 2001 Space Odyssey type thing, where it's a robot with a kind of face on a computer screen, and it talks to the crew whilst they're on the space shuttle. And they've suggested that it could be used throughout kind of missions to say, ask them questions that would typically be written down. So, how are you doing today? And you give them an answer. So it's an interesting approach, but a potential way of collecting data in this way. So there's kind of setting up the measurement. Then there's a few logistical things. I've already touched on a couple of them. But for the Statsy people in the room, I'm going to give you an equation now. So what happens if you take these guys and you give them this in that environment? It freezes. Yeah. You try and use technology like that in -20, and the battery's going to go like that. It's also fragile. It's probably going to break at some point, which means that you can no longer collect any data. And we learned the hard way doing this. We tried to do a fairly fancy study using microphones, physiological monitoring during an expedition in Greenland. On about day 3, I think all of the team members fell in a cold stream. The ice cracked and they all fell in. The equipment soon broke, and there was no longer any data to be collected in that study. So we learnt the difficult way, but it's something that we just completely overlooked. We assumed that that wouldn't happen because they were in a frozen environment and they weren't going to fall in running water, but clearly these things do still happen. So that's just one example of logistics. Digitization is fantastic, so it saves so many resources if you can get people to log stuff digitally. You don't have to then input it when it comes back, but sometimes it's just not feasible. Some of these areas are incredibly remote. There's no network signal. Even though you can tweet from the top of Everest nowadays, it's not, in some areas, you know, it's very expensive to transfer data back. There has been a recent study where in Antarctica they used mobile devices and people logged on it wasn't networked at the time, but they logged, and when they came back into somewhere with internet connection, it uploaded all of the data. That scares the pants off me, because if they're doing it on there, they're logging all their data and they get to day 60 and the phone suddenly breaks, that's all of the data gone. So it's a bit of a balance between making those choices and having a backup if you need it. There are conditions though where doing things like that are a lot easier. So we've done some work with the scientists at Concordia in Antarctica, which is a station. They've got internet, they've got computers, they've got all the resources they would need. So you can use them in some environments. Okay, so I'm going to just briefly move on to the analysis type approach now. So what will end up, if we use that kind of nested method that we've suggested, so you're getting that daily data from people, you're going to end up with a data set that has data within people, within teams, potentially within a larger organisation. So it's naturally nested. You know, it belongs to someone along the way. What that means is we need to use certain types of analysis when we're testing the data. Like typical kind of regression and ANOVA type stuff doesn't work, or it does work, but it's not the most appropriate form of analysis. So what we'd probably use is this multi-level mixed modelling with fixed and random effects. We might just want to test some simple questions, but we still need to do this. And that's because we might have 6, 10, 20, depends how long the expedition is, data points within someone that we need to control for that nesting, non-independence. So I'll give you a brief example. So we've been, over the past couple of years, collecting data from lots of different expedition teams going out into kind of deserts, mountains, jungles, all those sort of things. What we've got at the moment is a data set of 35 expeditioners. So we've got all these people, and within each person we've got multiple accounts from their expedition, so their daily logging. So we've got 705 days worth of data within these 35 people. The range can be from 5 data points for some people to 68 data points for others. All depends on how long the expedition is. So what we were interested in, whether we could predict affective responses in the expedition environment based on personality assessed before they went. So a kind of dispositional thing. Can that predict how someone reacts in general to the expedition environment? What you have to do when you're testing that data is, the first step you have to do is to what we call partition the variance. So you have to do something to control for the fact that you've got different numbers of days nested within each person. Before then you can test a kind of typical regression model. And that's the kind of the step that you would take with multi-level modelling. Once you've done that, then you're effectively testing a kind of typical regression. And what we found in that study was that gender, so this is looking at daily negative affect, so females tended to report more daily negative affect in the expedition environment than males. There's a question there of whether it's that they actually experience more negative affect or whether they're just more forthcoming in reporting negative affect. Probably the latter, I would think. But then there are also aspects of personality that were linked to negative affect scores at the day-to-day level in the environment. So being extroverted and being agreeable, so higher on those factors, was linked to lower reports of negative affect, which kind of makes sense. If you're extroverted and you're agreeable, you're probably going to engage more with your team members, be more affable as a teammate, so you're probably going to have a less negative emotional experience is the prediction. So there are some quite, I mean, that's a very simple example, but there are some quite cool things you can do. What you could then do with this data is go up another level and say, okay, we've got 4 or 5 different teams worth of data there. We could look at whether their teams differed based on some of these factors as well. So it's quite flexible and adaptable. So that's just looking at kind of, it's not cross-sectional, but it's looking at a kind of typical regression predictive approach. I did mention earlier that time is really important, so we're going to want to do some kind of testing over time. It can be quite simple. So this is a study we've just had published that I just found out this morning, got into the Daily Mail, so the pinnacle of the journalistic tree, where we looked at the effect of wintering over in Antarctica on crews stationed at the Concordia station. So 2 years worth of crews, 27 people, assessed before they went and then 9 times throughout their confinement period. We used a sleep diary, a positive and negative affect schedule and the Utrecht coping list. Just for a bit of background, Concordia is pretty remote, it's pretty hostile, so the mean temperature throughout the year is -51. In winter it goes down to kind of -80, so you can't really leave, you can't go outside. It's at altitude, so it's 3,200 meters, and it's 1,100 kilometers from the coast of Antarctica. You can't walk home if you fancied leaving. For 3 months or so, there's no planes coming in or out, so it's completely cut off from the outside world. So it's pretty harsh. What we found, you probably won't be able to see this very well, but the short story is using repeated measures analysis, so kind of basic statistical testing, we saw patterning of coping responses. And what we saw is that the quadratic effects fit best, and that tells us that during the winter period to the dark period, there's a complete drop-off in coping. So people kind of give up. But we didn't see a huge effect for changes in health or sleep. So what we've suggested and what other people have found in previous work is that actually in this period, it's probably likely that people realise that trying to just proactively cope with everything is useless because it's quite stressful, it's quite hard. So you give up, preserve energy, and then when the sun comes back, you have a rebounding of coping. When other people start coming back to the station, you start then re-engaging, which is quite an interesting finding, something to test again in future work. That's a really nice scenario because we've got a fairly good sample size. That's not always the case though. So this is a study we did with a team that skied across Antarctica. So there's a team of 6. They skied 1,100 miles from one side of Antarctica to the other for no real reason apart from that they just wanted to show that they could do it. It took them 68 days. We did some pre-expedition stuff with them, so we collected some data about who they were, and then we did a daily diary. So every day the team members completed a logging form in effect. And what we were interested in, there's a few aspects to this paper, but the really interesting part is that one team member had to leave at the South Pole. So they got to the South Pole, that person had been struggling for a few weeks, and they had to make a decision that they couldn't go on. So what we were really interested in there was answering one of those questions is what happens to a group when they've got a team member that's draining resources that eventually leaves. What we found was that the group improved in function as you would expect once that person had left the group. So this is a new method that was developed by a colleague, Dave Keatley, and it's called indicator waves. It uses standardized residual scores, it's quite robust to small samples, and it gives you a kind of an indication of whether something's more or less likely to happen using a chi-squared analysis. So just as an example, you'll see in the first half of the expedition, so this blue line at the top and then this yellow line is concern over team well-being, concern over team effectiveness. They're both much higher whilst that team member that's struggling is still with the team, and as soon as that person leaves, the drop-off is quite significant. So the team become more effective, they have less worries about how they're doing, and they're more able to complete the task. So that's just one example, but this indicator wave approach is quite interesting for looking at specific events and teasing out the effect that they have on the group function. And we assessed quite a lot of other stuff in there. The other thing you can do is, so this is a bit of a kind of a whiz through different types of analysis, but with these types of groups, when you're getting such intense data over long periods of time, you're effectively getting a time series data set. So you've got all these data points from these people in the environment. Typically, these small n type studies, you would have used kind of descriptive, so you would have looked at the graph and you would have tried to tease out what was happening and explain the effects that are being observed. But there's been some quite interesting new developments with dynamic modelling that have stemmed out of N of 1 trials, so kind of clinical work, that allow you to model this data looking specifically at within-person variability. So all you're looking at here is, in an individual, what's happening over time. There's some issues here about controlling for autocorrelation. So for this individual, what they say on day 2 is going to be affected by day 1. What they say on day 3 is going to be affected by day 2, and so on. So you need to control for that using a kind of cross-correlational analysis. We haven't yet applied this dynamic modelling to our work, but I'll just give you the high level of what has been suggested and why, if you're interested in using this analysis, how you could justify it to kind of reviewers or people like that. So using this dynamic modelling in a within-person approach is not as restrictive in terms of sample size, because you're only looking at that single case, that within-person variability. You're not aiming to generalise to populations, which is really helpful for extreme teams because they are quite unique, and we're not trying to say that they're the same as everyone else. It's always time series, so you've always got data that's kind of occurring over time. When you're including predictors in that, so if we're trying to explain those changes and you're including predictors, the predictors also need to be time series, so they also need to correlate with those effects. The number of repeated measures is the sample size. So if you've got this single person but you've got them monitored over 100 days, your sample size is 100, and that's where you get your power for testing that data. It's not about the total number of people. I made this point at the start, what's really important with these studies, especially when they're applied to extreme settings, is that they're quite bespoke. You have to be pragmatic, you're probably going to have to be quite creative, even if you're using them in kind of non-extreme settings, but with interesting populations that you might only be able to recruit a few people. The final point is that aggregation of data is possible, so using the same approach we've employed earlier with the multi-level modelling, you can then group the data together. So you can analyse it at the single case, but you can also then lump it in with other stuff to explore. I thought I'd just talk through that. You're quite lucky because Susan, one of the people that's been developing this N of 1 research, is coming to speak at Methods at Manchester in May, I think. So obviously she knows what this was all about, and if you're interested in applying some of those techniques, then it'd probably be a good person to come and watch. Just briefly before I finish, I just mentioned some of how you use this data to influence policy and practice. When we're doing this research, it's inherently applied, so it has a very kind of applied aspect to it. You're doing it so you can try and understand how people react. Obviously, the kind of bastion of academic work is publishing papers. That's our kind of currency. That's how you develop your credibility and integrity. So the publishing papers aspect is the thing that's kind of the first port of call, I guess. But there are loads of other ways. I'm not saying we're an expert at this, but we're using some of our results to feed into what the space agencies are doing, helping them develop practical resources for people going into extreme environments. We try and engage with end users and stakeholders as much as possible. So every year we go to speak at the Royal Geographic Society at their expedition conference, and we just try and get out and about amongst the people that could actually benefit from the work. And then I set up a kind of online teaching course just to kind of show people what you can get out of this research and how it can be applied and how it can be practiced. So it's, I guess, a bit about thinking outside the box and making some kind of contacts that might be useful for getting it out there to people. But that's what we've been doing in terms of influencing. So, I mean, I guess that's it. The take-home messages are, we kind of need to do this work with extreme teams to keep them safe and healthy whilst they're out in the field. There's lots of teams that could benefit from it. Studies with extreme teams tend to have small samples, so being creative in the design, using these kind of daily measurement approaches is really helpful. The context is key. So when you're designing studies with interesting populations and interesting places, really thinking about the context is really important, especially if they're going to be out somewhere away from kind of infrastructure like this. You have to think about how you're going to secure that data. Assessing time is critical when you're looking at stress. How people react on day 1 is not going to be how they react on day 30 or day 60. And then I guess so the methodological approaches will result in nested data, so becoming skilled in that kind of analysis is really helpful. And if you do all that sort of stuff, then you could probably have some fun with the populations and the data that you get from these extreme places. I think that is it. There's some references there, so if you did want to go and have a kind of a read of stuff, then I think you can probably send the slides around, Lisa, I guess. And that's it. If anyone's got any questions.